Okay, here we are in section 5.2, and we're going to talk about linear programming. Now, what is the difference between linear programming and what we've been doing? Well, you'll notice not much. Okay, the wording is a little different, but do you notice I kept the exact same um, thing that we're going to graph from the last problem, from the example? We have the exact same set of, well, before we called them boundaries, now we're going to call them constraints. Okay, because the idea here in linear programming problems is really simple. They're going to ask us to either maximize something or minimize something. Now, the this problem is asking you to maximize. So typically when we say maximize, they tend to use the variable p because they like to, for business majors, they like to say profit. Um, but if it was, so therefore, if it was a minimize, they might call it a C for cost. But it really doesn't matter what the variable is. You can make it smiley face and thunder and lightning bolts. It doesn't really matter. It's just a variable. And what we're going to try to do is figure out what x and y value will give us the largest profit. So focusing here, what x and y value for this equation here will give us the largest profit. So this equation here is typically referred to as our objective equation. And why do we call it objective? Well, objective means goal. Objective means what you're trying to do. So in this problem, our objective is to maximize profit. But you can't always just go willy-nilly plugging in numbers and saying whatever I want will work. Because logic would say I just want to do x but no y's, because y's are going to subtract, x's are going to make me bigger, and that'll give me a larger profit. But we all know in the real world, you have constraints. There are things that restrict you. There are things that you have to meet, like, I don't know, regulations, or your supplier can only provide a certain number of X, but when you buy X, you have to also get Y. It's just things like that. So what you have to do, step number one, is you have to graph your constraints to figure out where is your possible answers, where is your solution region. So, I know where I already have those graphed. Very interesting. Okay, there we go. There's our graph. So now I'm going to copy and paste that just down below. So I'm going to pause the video so it's going to happen like magic. Amazing. Look at that. I've already graphed it. It was so fast. Um, anyway, so there's my constraints. So now I know that any possible solution to this system lies in this shaded area. It lies in the gray area. So now the question is which of these points, which of these x and y values is going to give me the largest outcome for my p? Well, there's this theorem that says our max or min will always occur at a corner point, because the logic says, okay, if so we're looking at this corner point here, and we already found out that's 0, 3. And therefore, if this gives me whatever profit it gives me, then if I slide along the line here, and now I'm at 1, 3, and I got bigger, my values got bigger, because everything's linear, then 2, 3 is going to make me even a bigger profit, and 3, 3 is going to make me even bigger profit, and 4, 3 is going to make. So why stop in the middle? It makes no sense. I just need to check each corner to see which one gives me the biggest number, and I'm done. So therefore, what we're going to do is just take each of our three corner points, 0, 3. What were our other corner points? 5, 3, and 5, 1 half. So this was 5, 3, and then this point right here was 5, 1 half. I just have to test those three values, and whichever one gives me the largest profit is the winner. That's going to be my maximization. So I'm going to take my profit equation. So P equals x minus 3y, and I'm going to test it at 0, 3. And what do I get? What do I get? So that would be what? P equals 0 minus 3 times 3. So P equals 9, negative 9. So P equals negative 9. Okay, so I'm guessing if I'm trying to maximize my profit, that's probably not going to be the answer, or we're having a really bad year. But let's try the next point. 5, 3. So let's see here. P equals 5 minus 3 times 3. So therefore, 5 minus 9. So that makes negative 4. So clearly, if I'm trying to maximize my profit, I would much rather lose $4 or $4 million or whatever this means in your word problem, than I would rather lose $9. But I still don't want to lose money. So let's keep checking. 5 1/2. And logic says this is going to be the best one because as we already talked about, y's, when we looked at the equation, whoops, yeah, that's right, 5, y's make our values go down, and x's made our value go up. So this is just going to be 5 minus 3. 3 divided by 2 is either 3 halves or 1.5. So that gives us 3.5. So there is our maximization. So we have a max of 3.5 at 5 1/2, and that's how you would write your answer. Because it's not just asking. Well, actually, read the problem, figure out what it is asking. But when we don't know, you have to give all the information. What is your maximum amount? Well, our maximum amount was 3.5. But where did it occur? At the ordered pair of 5 1/2. And then that will result in the largest value in this shaded region. Now, will this 5 1/2 always result in the maximum amount? Well, no, it only did that because this was x minus 3y. If it wasn't x minus 3y, it could have been any of the other corner points. But we do know, because these are linear functions, it will always occur at a corner. That is the big leap from 5.1 to 5.2. You do the exact same thing you did in 5.1, except now in 5.2, all you're going to do is take your corners, plug them in, and see which one gives you either the largest number or the smallest number. And the key to this is remembering it's linear programming. Everything is lines. So the word problems that you see in Chapter 5 should be very, very similar to the stuff you saw in Chapter 3 and 4. The only difference is now these word problems are going to ask you questions about maximization or minimization. Okay, that's it. So write your summary, figure out, summarize it for yourself, and start doing some homework. All right, see you in the next chapter.